I'd like to welcome you to this webinar, and what I'm going to do is run through a few slides and tell you about the engineering program here at Dartmouth, the dual degree program. I'm not going to say everything that's on all of these slides. There's more information on some of the slides and we'll have time to go over. Nonetheless, it's probably interesting to you, and so you'll be able to look at that when you download the slides. Dartmouth is a liberal arts college with 3 professional schools of engineering, business, and medicine. The dual degree program makes use of both the undergraduate college and the Thayer School of Engineering. The Thayer School was founded in 1867. It's one of the country's oldest professional schools of engineering. The thing that's distinctive about the Thayer School is the commitment that we have to creating liberally educated engineers. We want engineers that are not only technically capable, but also have the breadth of awareness that comes with a liberal arts education. We think that this gives our students and graduates an advantage in the workplace and in the real world when they're doing engineering, not only in knowing how to build things, but also knowing what to build, and also being very successful in organizations where they need to have a breadth of understanding of all the things that go on in an engineering problem. The degree, we offer 5 degrees here. The Bachelor of Arts degree in Engineering Sciences is the one that the Dartmouth students get. You will get a Bachelor of Arts degree from your school. The Bachelor of Engineering degree is the one that you would be most interested in. That is the one that you get after completing the dual degree program. If you really like what you're doing and you want to stay on at the Thayer School, we have 3 graduate degrees in Master of Science, Master of Engineering Management, and a PhD. Typical dual degree students are natural science majors or math majors or computer science majors. They're interested in either a career in engineering and or preparing for a graduate program in engineering. They're open to spending their junior or senior year at Dartmouth and coming back for a 5th year at Dartmouth. And they're looking for a hands-on engineering program. You get to build a lot of stuff while you're here. The class sizes here are pretty small, and we have very strong student-professor interaction. A few more facts about Dartmouth, things like food and performing arts and athletics. One I would like to direct your attention to is at the bottom of the slide. We have a number of trips and educational opportunities for the students here, including what Dartmouth calls the first-year trips, which is when first-year students, incoming students, go on hiking trips or canoeing trips in the White Mountains of New Hampshire. This is a very exciting time for people just to kind of get to know each other and learn more about the fun side of Dartmouth. And as a dual degree student, they run special first-year trips for exchange students and transfer students. And so as a dual degree student, you would be eligible to go on one of these, and we highly recommend it. They're great fun. Thayer School is a pretty exciting place. You see a lot of students working together, collaborating on projects. It's a very collaborative engineering environment. It's not a highly competitive against each other engineering environment. Even when we do have competitions, like the students riding their little wiggle cars there on the slide, it's all in great fun. Just a great way to enjoy what you've done at the end of a term, to have a good-natured competition at the end. The dual degree program, you spend either your junior or your senior year at Dartmouth. That's the first year of the program. And then you come back for a 5th year to earn the Bachelor of Engineering degree. In the junior or senior year, in your first year in the program, you take 6 engineering courses and 3 courses outside of engineering. I have more to say about that later. Dartmouth is on a quarter system. That is, we are sometimes called a term system. We have 4 10-week terms a year, fall, winter, spring, and summer. Students take 3 courses per term, so over the course of an academic year, 3 terms, you would take 9 courses, and in the program then 6 are engineering courses, 3 in the humanities and social sciences. Your Bachelor of Arts degree comes from your home institution, majoring in whatever it is that you choose to major in, math, physics, whatever. You then return to Dartmouth for your 5th year to earn the Bachelor of Engineering degree. After your 5th year, you can get an engineering job. The Thayer School has an excellent career services center that sponsors activities throughout the year. We'll help you learn how to write a resume. We'll set you up with recruiters. Or you can apply to graduate school. And The timing of the program, whether you do the junior year or the senior year first, is a program decision that's usually dictated by your home school. Some schools really like the students to come in the junior year. Other schools prefer for them to come in the senior year. If you come in the junior year, you'll spend your freshman and sophomore years at home taking prerequisites, taking your liberal arts courses. And then you come to Dartmouth for the junior year. You have the 1 year of studying engineering here. You go back. You finish your senior year. You do an honors thesis. You do the usual senior year things. Tell your friends what a great time you had. And then you come back for the 5th year to get the Bachelor of Engineering degree. The other approach, which is the more traditional 3-2 that a lot of places have, you do your freshman through junior years at your home college, and then you say goodbye and you come to Dartmouth for your senior year and the Bachelor of Engineering year. Whether you come as a junior or a senior, your first year of the program can begin in the summer or the fall. Remember, Dartmouth goes 4 terms a year, summer, fall, winter, spring. So typically students will come in either the summer, the fall, and the winter, or they'll come for the fall, winter, and spring. Depending on what you're interested in studying, starting in the summer or starting in the fall will be more advantageous. For example, electrical engineers, it's really a good idea if you can to start in the summer. The courses just line up really nicely if you start in the summer. It's not terrible if you start in the fall, but it lines up really nicely if you start in the summer if you're interested in electrical engineering. The other disciplines of engineering, you can look at the dual degree sample programs that your advisor should have that you can look at to see how the different programs work out. Something else you can do between in the summer or in the off term, whether it's summer or some other term, maybe spring, is to pursue an internship in industry. And again, our Career Services Office can help you identify and find an internship. To prepare for the dual degree program, the minimum preparation are 7 courses, 3 calculus, 2 physics or chemistry, and a computer science course. Calculus, you should have calculus through vector-valued functions. That's usually 3 courses. Some schools are able to do it in 2, but usually it's 3. In physics, at least 2 courses. You'd obviously have more if you're a physics major. It's the usual first-year sequence, mechanics in the first course and electromagnetism in the second course. Some colleges, in their physics programs, if you're a physics major, they like you to do modern physics, quantum mechanics, for the second course, and then electromagnetism as a third course. That would be okay too. Then chemistry, at least 1 course in chemistry.
Hi, I'm looking for Carrie Fraser.
Sorry, she's not here right now.
Okay, is she gone for the day, do you know, or?
1 moment, please.
Okay.
Sorry. Okay, we're back. I got interrupted by a telephone call that wasn't for me. At least 1 course in chemistry, and then 1 course in computer science or computer programming. Now, these intro courses, especially in chemistry and computer science, these should be courses that you take for credit if you're going to major in one of those subjects. So, for example, the intro computer science course should be the first course for a CS major. It shouldn't be a course for non-majors that's devoted to, say, learning how to do web programming or something like that. This is the real first computer science course, likewise the first course for a chemistry major and so forth. We do honor AP credits or IB credits. If your college puts a credit on your transcript towards graduation for an AP test or an IB test, we will honor that if it's on your transcript. Additional courses beyond these minimum courses we strongly recommend. You're probably doing those anyway if you're majoring in science. And we consider those courses in evaluating your application. So it's best to do courses beyond the bare minimum. Now, when you come to Thayer School, and you come into the first year of the dual degree program, these are the courses that you will take. This is give you an idea of what engineering students do here. You must take Engineering 21, the Introduction to Engineering. It is a course completely devoted to design and problem solving. So you're divided up into teams, you're given a general problem to solve, and you go 0 to prototype in 10 weeks. You build it, you do a rudimentary economic analysis, you check to see if it's been patented, a variety of things surrounded with bringing a product to market. And then in the end, you get to demonstrate your project. And every now and then, one of these projects gets patented and even becomes a company. The second required course is Engineering 22. This is a very different kind of course. It's a very mathematical and physical course in which we show you how your calculus and physics and chemistry that you did in your prerequisite courses are applied to a variety of engineering systems, whether they're electrical systems, mechanical systems, chemical systems, whatever. It's a course that tries to integrate all of those things, and it really introduces you to our broad philosophy of understanding how to think about engineering problems. Third required course is Engineering 23, Distributed Systems and Fields, which continues the kind of broad approach that's taken in Engineering 22, but it looks at systems that are described for which you need vector calculus and partial differential equations to do the analysis and the modeling. If you are taking or have taken or will take an intermediate course in electromagnetism, for example, you're a physics major and you take that junior level E&M course, that intermediate E&M course, then we waive the Engineering 23 requirement because there's considerable overlap between an E&M course and Engineering 23. So beyond those three courses, you should, in the first year, you'll take one or two of the core courses, Engineering 24 through 27. These courses, again, are broadly applicable to a variety of engineering problems. They're not specifically one kind of engineering or another. They're broadly applicable, again, continuing to build that broad foundation. And then you'll take one or two of what we call gateway courses. These are courses that are specific to particular branches of engineering that give you an introduction to that branch of engineering. So, for example, Engineering 31 and 32 are for electrical engineers, 33 and 34 are for mechanical engineers, 35 and 36 are for chemical engineers, and then 37 and either 34, 35, or 36 is what you would do if you wanted to do environmental engineering. You can learn about all of these courses in more detail if you go to our website. So first year, 2 or 3 of those required courses, the must-takes, 21 through 23, 2 or 3 of those. And then 1 or 2 of 24 through 27, and 1 or 2 of 31 through 37. Eventually, you'll take 2 of the 20s and 2 of the 30s for your Bachelor of Engineering degree. The thing you want to do in the first year is take the courses that will prepare you for the advanced courses that you want to take for your concentration when you get to the 5th year. Also in the first year, there are those 3 non-engineering courses. Those are electives. We intend for those to broaden your liberal arts education. We do not recommend, in fact, we strongly do not recommend that you use these electives to take science courses. So please don't plan to come here and take 6 engineering courses and 3 physics courses. We don't think that's a good idea. The engineering courses, students will tell us, and we know, they'll keep you plenty busy all by themselves. So use these courses to take humanities and social science courses elsewhere in the college and just take advantage of the broad array of things that you can study at Dartmouth. Now, we do understand that very often a student comes who, because of the requirements of your major and the way the courses work out, the way things line up at your school, there may be a required course for your major that's offered every other year, and you're coming to Dartmouth in the year when it's offered, so you'd miss it, and you really need that course. We can work with you to work that course into your schedule in a way that isn't too hard. So, and we can consult with you on a case-by-case basis if you really need to take that science elective. There are ways to make it work. When you come back for the Bachelor of Engineering year, there are 9 courses again. The 5th year is usually all engineering, maybe a science course or 2, but usually it's all engineering. 2 courses that are required are Engineering 89 and 90. Those are the big design project for the Bachelor of Engineering program. This is where you, again, are in a group of students working on a project. This time the project comes from a real industrial sponsor, so you have that experience, as much as we can create, as much as we can make happen here, of working with an industrial client. So that's a 2-term project. It's a very big deal, and it really culminates everything that you've been doing. You also will take, required to take an applied math course. So one of those 3 courses, 91, 92, 93, that's numerical analysis, Fourier transforms, or statistics. And then once you've done those three required courses, you take 6 more engineering courses to fulfill the breadth and depth requirements of your particular concentration. And you can learn more about what the requirements are and see some sample Bachelor of Engineering programs if you go to this website that's shown on your screen. Now, financial aid. This, of course, is very important. In the first year, Dartmouth has no financial aid available to the dual degree students. Okay? You are officially an exchange student at Dartmouth, and Dartmouth does not give financial aid to exchange students. But many schools do provide aid for their students to come here. In other words, your financial aid from your home school may follow you to Dartmouth. Ask your advisor at your school about how financial aid works for the dual degree program. It varies from school to school. In the 5th year, you are now a student not in Dartmouth College as an exchange student, but you are a full-blooded student in the Thayer School of Engineering with all the other Bachelor of Engineering students, the ones that came up through Dartmouth, who are also spending 5 years. And you have financial aid available from the Thayer School of Engineering. It's need-based up to a maximum of full tuition. So there's no aid available for room and board or books or anything like that, just tuition. Depending on your financial status, depending on your citizenship, loans may be available. And if you have questions about that, just send us an email and we'll put you in touch with the right person. Something else I want to point out is that the Bachelor of Engineering degree is considered to be an undergraduate degree. Consequently, when you fill out the profile and the FAFSA for the 5th year, your parental resources will be considered. So mom and dad aren't off the hook in the 5th year. First year on campus, we want you to live in the dorms. It's required that you live in the dorms. You have an opportunity that way really to get integrated into the Dartmouth community, get to know a lot of students besides just the other dual degree students. The meal plan is mandatory. I think the food's pretty good here. Students probably tell you different stories, but in the BE year, you're off campus living on your own. There's no student housing for BE students, and there's no meal plan available. Although you can pay cash money at any of the eateries on campus to get food, or you'll probably be doing some cooking for yourself as well if you're living in an apartment or a house. Now, how do you apply to the dual degree program? The first thing to do is to get approval from your college. Make sure you understand how the program works. Make sure you understand the financial aid implications. Review whether or not courses that you can take in the dual degree program, engineering courses that you take at Dartmouth, can be transferred back for major credit. Some colleges do allow you to count certain engineering courses as electives. For example, if you took material science or thermodynamics, that might transfer back to your college as a physics elective. It's up to the college, it's up to the department. So talk to your dual degree advisor and find out what they will do. See if it works with your program. Then obtain an application form. You can either get that on campus from your advisor, or you can download a PDF file from our website. Either way, get a copy of the application form and fill it out. And get a recommendation letter from either your dual degree advisor or another science professor who knows you well. It may be, for example, that you're a biology major and the dual degree advisor is a physics professor. You may not even know the dual degree advisor and they don't know you. In which case, talk to a biology professor who knows you well and get them to write you the recommendation letter. We want someone to write about you who really knows you and can give us a really good, clear picture of who you are and how you would fit into the program here. In addition to the application, it's going to require you to write an essay, and it's going to require you to submit a copy of your CV, or your resume. So if you haven't got a resume put together, this would be a good time to start doing it. Return the whole business, put it in an envelope and mail it to us as soon as your fall semester grades are available, and no later than February 1st of the year that you're applying. So if you're a sophomore and you're applying for the 2111 program, no later than February 1st. If you're a junior, no later than February 1st of your junior year, depending on whether you're coming for the 2111 or the 32. And just mail it to Jenna at the address there on the screen. We will notify you of your acceptance on or around March 18th of 2011. In some cases, midterm grades for the spring semester are requested, and that will delay your decision. It sometimes happens, for example, that a sophomore, you've only been there 3 semesters, you haven't taken all the prerequisites yet. We especially are interested in your physics grades and your advanced calculus grades, and if you aren't going to take those classes until the spring semester of your sophomore year, we may wait your decision until we've seen the midterm grades in those classes to see how you're doing. We generally receive more applications and places available. Last year we received a lot more applications than we had places available. So we are going to turn some people down. We don't really want to, but we are limited in how many students that we can admit. And we do keep a waiting list. And we ask students that we admit on March 18th, we ask them to commit to us by April 4th. And that way we'll know who's coming and who isn't, so we then know who we can admit off the waiting list. And if you are admitted off the waiting list, we give you obviously more time to tell us when you're coming or if you're coming. We often get asked about the BE year. Do you have to reapply to come back for the 5th year? And the answer is no. If you do well in the first year, then and we assume you will, almost everybody who comes here does well, your admission to the 5th year is automatic. So what will happen is we'll need you to fill out some paperwork to tell us you're coming and to apply for financial aid and to tell us what courses you plan to take. So you'll receive those forms to fill out sometime in your senior year. Okay. So that's how the acceptance works. And with that is the last slide. So I would be so what we're going to do now is take your questions and see how many we can answer. Thanks for coming.
Thank you, Eric. This is Carrie. We have received several questions, and some of them I've typed in the answers to. I want to encourage anybody on the line who has a question that hasn't put it into the question chat, please do so. We got one question around taking other science courses during junior year, and I think as Eric mentioned, this is generally highly disrecommended, but exceptions can be approved on a case-by-case basis, and we'll work with you on that.
Sure. Can I give an example?
Sure.
Okay, let me give you an example of how this might work. If you add up the total number of courses required for the Bachelor of Engineering degree, it is possible to complete all the requirements for the BE with 5 engineering courses in the first year and 9 in the second year. We will make an exception to allow that to be done for a dual degree student if, for example, you really need to use that 6th course to take some very intense science course. And again, we do that on a case-by-case basis. It really depends on what you're trying to study, but that kind of thing does happen. The other possibility, a lot of it depends on whether it's feasible or not. We definitely don't recommend it for the first term you're here because you're just getting used to the place. Every dual degree student who comes says, wow, that 10 weeks went by really fast. I'm from a semester school and we're used to 15 weeks or something. So we definitely don't recommend that you do an extra course in your first term. But in the second or third term, if you're doing really well, then it can work. The real key to whether or not it's a really bad idea or not is whether or not the course has a lab. You know, if you've got an engineering course with a project, and you've got another engineering course that has a lab, and then you want to take, you know, worst case scenario, organic chemistry, right, with 6-hour labs, we would definitely not recommend that because you're just going to be all labbed out. It just becomes very, very difficult to do. On the other hand, a student that wants to take a mathematics course where there is no lab, there is no project, you're just doing lots and lots of proofs and homework problems. That may be very, very doable. It really depends on the course you want to take and the other engineering courses you're taking with it. Okay?
Okay. Our next question is a chemistry course at college necessary for applying?
You absolutely need chemistry for the Bachelor of Engineering degree. It is a requirement for the degree. Okay? It is also a prerequisite for some of the engineering courses. Depends on the course, of course. So you absolutely need chemistry sometime. Whether or not you take chemistry before you come into the dual degree program depends on a couple of things. We'd like you to do it. Every now and then there are students who just can't squeeze it in. You know, you're a physics major, and many physics majors don't require their students to take chemistry. So maybe you're a physics major and you're applying on the 2111, and your first 2 years have really been taken up with doing calculus and getting into your physics major and doing those requirements, and you managed to squeeze in the computer science course, but the chemistry one just didn't happen. That's okay. You could either take chemistry at Dartmouth if you really needed it, or you can go back and take it your senior year, as long as you get it before you come back for the BE, because it is an absolute no exceptions requirement for the Bachelor of Engineering degree. So it is possible to come without having had chemistry, but it's not possible to complete the program without it.
Okay, thanks, Eric. The next question is your engineering specific to a particular area, or is it a general engineering program?
The first year, we really want you to develop the breadth. That's the intent of the courses in the 20s. In the 30s, you get a chance to explore different disciplines. And in the BE year, we expect you to concentrate on something. So we don't have a set of rigid requirements that you must follow this plan if you want to be an electrical engineer, but we do have suggested programs that say if you want to be an electrical engineer, these are the courses you ought to take because this is what electrical engineering is. So the disciplines that we support here that you can specialize in are electrical, mechanical, chemical, especially biochemical, environmental, material science, and you can do computer engineering here. What we don't have explicitly are things like nuclear engineering, aerospace engineering. We don't have those. Although we have had students who have come through and gone on to graduate school in aerospace in particular, because it turns out that our broad program through the BE is actually excellent preparation for studying aeronautics.
Thank you, Eric. Well, it appears that, we have a new one. So will my degree be a specific engineering degree, for example, in electrical engineering?
No. Your diploma will say Bachelor of Engineering. However, you can say anything you want on your resume. And so, for example, we will tell you if you are an electrical engineer, then you put on your resume, I did the Bachelor of Engineering degree from the Thayer School. I concentrated in electrical engineering. I took these courses. I did these design projects. I had this or that internship. And so you paint a picture of yourself on your resume as an electrical engineer. And then anyone who looks at your resume will know that you are, in fact, an electrical engineer. They'll never ask to look at your diploma at an interview.
Okay, our next question is, some of our partner 3-2 schools require the Intro CS course to use a specific language or tool, for example, MATLAB or Java. Our Intro CS sequence uses Python as the intro language. Is that a problem? And that's coming from St. Lawrence.
No, it's not a problem at all. We want the students to get exposed to what you learn in a first computer science course, and that really is independent of the language. What you learn in an intro computer science course is how to think, how to do computational thinking, how to break a problem down logically, how to compose a computational solution to the problem, and how to debug the thing and make it work. And that can be done whether it's in C or Java or Python. It really doesn't matter. Here at the Thayer School, we allow students to either take the computer science department's intro course, which is in Java, or we have our own course in which we teach C and MATLAB. And it's very true that MATLAB is the preferred number crunching language for all of our engineering courses. But you're not really at a disadvantage if you don't know MATLAB coming in. One, there are many good online tutorials where you can get the rudiments of MATLAB pretty easily. Second, the Computer Center at Dartmouth does little MATLAB mini courses every term where you can go in and learn the rudiments. So it's really not a terrible thing. Once you understand how to think computationally and have learned it with the first language, the second language comes a lot easier.
Okay, our next question is, will we get specific advisors at Dartmouth to help us plan out our courses?
Yeah, so in the first year, I'm your advisor. But once you've settled into and you know really what area you really want to pursue and focus on, or if you just find somebody you like better, you're absolutely welcome to go and have that person be your advisor. I usually advise all the first-year dual degree students because I can help them kind of navigate, putting their programs together for the first year. But once you get into the second year, when you get into the BE year, then we really like for you to have an advisor that's in your area. So I'm an electrical engineer. I could probably advise a mechanical engineering student, but you'd probably rather have a mechanical engineering prof be your advisor when you come back for the BE.
Okay, Eric, the next question is, the program guide says there's sample programs in biomedical engineering, and I didn't hear it mentioned. Is it possible to concentrate in this field?
Yeah, it is. Biomedical engineering is probably our biggest graduate research area. It's one of the three that we concentrate in at the graduate level. The other two are energy and complex systems. And we are very active in biomedical engineering at the graduate level, and a lot of research opportunities for undergraduates in biomedical engineering. If you look at our course catalog, you'll see that we haven't got a lot of undergraduate courses in biomedical engineering. We have a couple of intro courses and we have several graduate courses. And it's certainly possible to put together a good BE program in biomedical engineering. Recognize, however, that really if you're going to work professionally in biomedical engineering, you're going to want to go to graduate school and take at least a master's degree and very possibly a PhD in biomedical engineering. So yes, you can, and the sample programs are in the catalog.
Okay, our next question is, how do dual degree students perform relative to non-dual degree students? Do they feel sufficiently prepared? So I'm going to hand this question to Dan Harburg, a student from Middlebury who participated in our dual degree program here.
So the answer to that question for me was that I definitely felt sufficiently prepared, without a doubt. Many of the other students had taken no more than the prereqs that I had also taken. So they had completed similar prereqs here at Dartmouth, but didn't have any more classes than I had. And I actually felt that some of my more advanced physics classes that I had taken actually prepared me better for certain things that I took when I was here than students who were just here. So there certainly isn't a problem, and this was the same thing with other students that I was with in the same time. So I would say there's no problem with that.
Okay, thanks, Dan. The next question is, if I'm taking some intro to engineering courses with my college of other 5 colleges, will that put me at an advantage with the program?
Yeah, so for example, this sounds like you might be at, say, Mount Holyoke and interested in taking engineering classes at UMass or at Smith. That's a really good idea for just trying out if you happen to like doing engineering. So that could be a fun thing to do if that's something that you have time to do. Certainly, if your application, it certainly demonstrates interest on your application. And if you've done well in those courses, it shows that you can do it, right? But I wouldn't say that it's essential, and I wouldn't want you to do it and then at the cost of not getting the liberal arts education at your home school, and especially or cutting on the science background. So it's a great thing to do if you can fit it in, but it's certainly not essential, and I guess that's what I'd say.
All right, thank you, Eric. I think we've run through our questions. And so, Eric, will you please advance one more slide?
Sure.
So thank you all for coming to our webinar. Feedback is very welcome about the webinar process and about the program. Here are two ways that you can ask questions voice to voice. One is the phone number, the other is through an email connection. You will also receive a follow-up email within a couple of days after attending the webinar with further details and links, including links to the slides for the presentation today. So thank you again for your participation and your questions. We look forward to hearing back from you. And that concludes our webinar for today.